Hello and welcome to the second speedrun of today. We're going to be continuing our exploration of systems of linear equations and solving chapter 3.6 of the IB Math textbook. So let's jump right in. So in the previous video, we looked a lot on solving our system of two linear equations, but we want to see if there's an easier way maybe to solve a system. So let's look at a general formula for solving any system of linear equations. So we have our first two variables, we have our second two variables, and we have the two constants that they're equal to. So how can we manipulate this to give us a formula? Well, first we can multiply the top by d and the bottom by b. So we can have a dx plus b dy is equal to e d, and this is to make the coefficients of y equal. So we have bcx plus bdy is equal to fb, or bf really, it should be de and bf. So now that the coefficients are equal, we can equate the two. So we have adx minus bcx is equal to de minus bf. And so we have x is equal to de minus bf over ad minus bc. So that is going to be our x value. So if we notice, if we go up here, we'll substitute it back into this equation. Ax plus by is equal to e. So then we have a times ade minus abf over ad minus bc plus by is equal to e. So we have by being e minus ade plus abf. Well, actually this is minus though. Over ad minus bc. So put brackets around that so we don't get confused. So we can multiply this, convert it into this fraction. So we have ade minus bce minus ade plus abf effectively. ABF. And so if we cancel these two out, we're left with ABF minus BCE over AD minus BC. So that's equal to BY. So Y is actually equal to this divided by B. In other words, AF minus B minus EC over AD minus BC. So this will be our y value. And so, well, to solve the system, x will be the pair xy will be equal to scrolling up, de minus bf over ad over ad minus bc, comma af minus ce over ad minus bc. So yeah, this can help you simplify some of these linear equations into maybe a more understandable form. Then we can jump into some questions. One last note though, ad minus bc should not be equal to 0 since we're dividing by it. And so if it's equal to 0, this will be invalid, and so there will be no unique solutions if ad minus bc equals 0. So let's go into some questions.
Hello, sorry about that. I'm back now, and so let's move on to some questions where we can use this concept. So we need to solve the two systems of following linear equations. The first is 3x actually, let's make this a bit bigger. 3x plus 1 plus I, y, is equal to 4 plus 5i, and 4 minus I, x, minus 1 minus I, y is equal to 7. And remembering the formula that x is equal to dE minus bf over AD minus BC, and y is equal to AF minus CE over AD minus BC. Let's plug in the numbers. So we have D as negative 1 minus I. So we have negative 1 plus I times E, which is 4 plus 5i, minus BF, and B is 1 plus I times 7, and we need to make it all over AD minus BC. So that's 3 times negative 1 minus I, so negative 3 times 1 minus I, minus 1 plus I times 4 minus I. So if we multiply all this out, we will get negative 4 plus 4i minus 5i minus 5 minus 7 minus 7i, all over, and then this would be negative 3 plus 3i minus 4 minus 4i plus I plus 1. So if we add all of that together, we will get negative 16 minus 8i over, this is negative 6 it's just negative 6, isn't it? Yeah, it's just negative 6, all over negative 6. And so we know this is equal to 16 over 6, which is 8 over 3 plus 4/3 I. Okay, how about our other fraction? Well, we have AF, so AF being 3 times 7 minus CE, which is 4 minus I times 4 plus 5i, all over, well, it's AD minus BC again, which we know is negative 6. So let's look at what this is. This is 21 minus 16 minus 4i minus 20i. Oh, sorry. This is 16 plus 4i minus 20i minus 5. Yeah. Okay, and so that's equal to all over negative 6. So this is equal to 21 minus 16 minus 5, this is 0. So it's simply negative 16 over I over negative 6, or in other words, negative 8/3 I. So x is 8/3 plus 4/3 I, and y is 8/3 I. And that should be correct, but let's just check our answer to be sure. Oh, hold on. Why is this plus 1? This should be minus 1. Sorry about that. So if that's minus 1, this is actually negative 16 minus 8i over negative 8. So let me just clear all of that quickly. This is over -8, so this is -2 minus I. And then y, of course, would be -16I over -8, so that's going to be 2I. So, sorry, this would actually be 2 plus I, x is 2 plus I, and y is 2I. So those would be our two answers. Okay, on to the next question. And the final question is just another one, 1 plus 4I x plus 3IY is equal to 2 plus 4I, and 3 minus 5I x plus 5 plus 4I y is equal to 21 minus 27I. So if we quickly input this, we have DE, so 5 plus 4I times 2 plus 4I minus FB, so that would be 3I times 21 minus 27I, all over AD minus BC, so that's 1 plus 4I times 5 plus 4I minus 3I times 3 minus 5I. So what is this? And this would be 10 plus 4I times 2, 4I times 5 is 4I times 7, it's 28I, minus 16, minus 63I, plus, it's still minus 30. Oh, sorry, no, 3 times 27 is not 30, that's 81. All over 5 plus 6 times 4I is 24I, minus 16 minus 9I minus 15. Okay, and so this would be equal to 10 minus 16 minus 81 is 81 minus 6 is minus 87, plus 28 minus 63, that's plus 4 minus 9 plus 5 is minus 35I, all over 5 minus 16 minus 15, negative 30 plus, negative 31 plus 5 is negative 26, plus 24 minus 9 is going to be plus 15I. So this is going to be our x value. And yeah, that's pretty complicated, I'd say. But what is our y value? Well, our y value is, if we go back to the equations and we need to get AF, so 1 plus 4I times 21 minus 27I minus EC, so this is minus E, it's 2 plus 4I times C, so that would be 3 minus 5I, all over this other number, which is negative 26 plus 59. So what would this be? Well, this would be 1 times 21, 21 plus 84I minus 27I plus 27 times 4 is 108 minus 6 minus 12I minus 10I. Hold on. No, 6 minus 12I plus 10I minus 20. All over this number below, so all over negative 26 plus 15i. So this is 21 plus 108 minus 6 minus 20. So that's going to be 108 minus 6, which is 102, plus 1, 103. And then 84 minus 27, 64 minus 7 is 57. Minus 12i is 47, 45, plus 10i, 55, plus 55i, over negative 26 plus 15i. And yeah, I think that should be it. I don't know. I don't think the book is correct in this one, since we have 21 times 4i. And yeah, that seems a bit off, that they're suggesting that this would be a negative 56. So unless I've missed some massive sum, which I don't think I have, I think this answer should be correct. So yeah, that's all for the speedrun, and I hope to see you in the next one.